I wanted to do a little bit of looking at area and paper folding. The first part I'm going to do can be done with any size sheet of paper at all. I'm going to use Post-it notes to go over this simple process. Then I'll move from that to looking at squares, which is more specific. When we think about a rectangular piece of paper, we often talk about folding it in half. Normally what we mean when we say that is half the area. So I'm going to fold this piece of paper in half. And when we look at it, we can clearly see that it's half the area. I've basically taken the height, cut it in half. Or from the point of view of congruent figures, I have two congruent rectangles, each one of which is half the area. So that's folding in half. But let's look at folding in half a different way. Starting with the same rectangle, I'm folding up sort of a random distance. It does not matter how far this is. Just need to match up with the edges. I'm now going to fold the other edge down to match this. I've now made a rectangle that is half the area. But my first fold appeared to be totally random. A lot of students will find this somewhat surprising. So we're going to look at this from the point of view of mathematics a little bit. And we can talk about it in terms of geometry too. In terms of geometry, I'm going to unfold this. And then I'm going to draw a line here. That's where I folded to. So we can see that this is two congruent rectangles, and this rectangle right here I've cut in half. I've done the same thing with this rectangle. I've cut it in half. These two rectangles add up to the whole thing. I split both of them in half, so I'm going to get half the area. But now we're going to look at it from the point of view of algebra. Let's say this length right here is A. Well, this length over here isn't A, it's clearly something else. We'll call it B. So I've got A and B right here. If I unfold this, I can now put the B here and the B here, since we know we combine those two. Similarly down here, this was A and this is A. So if I look at this, I've taken the height and split it into four pieces. Two of them are A's, two of them are B's. So you have 2A plus 2B. Yet, when I do the folding, I just have 1B and 1A, or A plus B. It's clear that this is half as big as that. Even a fourth grader can see that connection. People talk about working with variables as challenging, yet by creating visual models where we can clearly see A and B are different, students can get a much better feel for the subject. Next thing I'm going to do is move to squares and folding squares in half.